Hi everyone, my name is Krzysztof. I'm going to tell a few words about myself because if I were famous, I wouldn't be scheduled just before the lunch break. But anyways, so I used to work at Facebook, specifically on the React Native for Android, almost since the project started. I left Facebook end of last year, moved to Poland, and now I work for a company called Software Mention. We build web and mobile apps using React and related technologies. And I actually have one more slide about my company because I'm really excited that my team have released on Monday actually one product for one of our clients. It's Otcha.tv, and it uses the most hip stack possible at the moment. So React Relay, GraphQL, React Native, everything's there. Go check it out just after this talk because it has a lot of addictive content. Yeah, let's start then. Yeah, so this talk is going to be about animations in React Native. So Eric actually earlier explained why animations are important. The point is that we can use animations for various things, so including like making the transitions very smooth to collect users' focus. And there are also like a lot of those small things that people don't really even notice in your app, but they animate, and they adds up to create a great user experience. So animations are very important. And for the purpose of this presentation, I also simplified a couple of diagrams. So if you see people start shaking, those are my colleagues from Facebook. All right, so let's start. Native components animations are the first type of animations we can. It's the first way how we can get things to animate in React Native. So those are just native components built into the platform, and when we use that just by rendering that component, one of the examples would be Navigator.ios, where you can see that there are many things that animates on that screen. So for example, the screen that swipes from the left, you can also interact with that animation, so you can drag your finger from the edge of the screen, and this way it will like navigate back. And also while you're dragging, there is this fade in, fade out animation for the header. So this is all available out of the box, and actually React, the JavaScript doesn't have anything to do with that animation. You just render it, and it works as it would work in the real native app. So another example is the map view. So it also has those like these types of animations. They're available out of the box. So when you zoom in, there are like things that appear, and when you zoom out, there are some things that disappear, and so on and so forth. There are some components like that on Android too. So for example, the ripple effect is running on native. So this is just a native component that renders that animation when you like hold your finger on a button. There's view pager as well on Android. So it also allows for interaction with gestures. So when you drag your finger around and then release it, then it animates to the next page or previous page. And there is also this animation when you reach the end of the view pager like that. So it animates this overscroll. So the benefits of using these types of animations is that they have maximum possible performance. So JavaScript doesn't do anything when this animation is happening actually, and they're also specific to platform and consistent with platform behavior on the native apps. So for example, like the speed of the navigator is gonna, like the speed of the transition for the navigator is gonna be the same as in all the other apps. And also this overscroll, for example, animation is gonna be consistent with your Android versions. But it's only available for a couple of components, and there is a limited set of those. You can build your own, but it requires you to actually interact with the native code. And it's also not very easy to customize the behavior. Second type of animations are layout animations. So layout, the API is very simple. In JavaScript, you call layout animation.spring or layout animation.linear. There are several drivers, and then in your code somewhere somewhere else, you got set state that is going to update a status, update the component. So once the component re-renders, it will render different state. In the example on the left, there is a simple app that has one component in the middle that is centered vertically and horizontally. And in that component, we're adding new elements. Whenever you click on a button, we change the state, and we're adding new elements. And since it's centered, then whenever we add a new element, then the position of the remaining elements needs to change. So when we add a new element, then the elements on the left needs to animate left, and when you add the new row, then the elements need to animate up. So this is all handled by the layout animation, and the only thing you need to do is just call this layout animation.spring before you change a number of elements for that component. And how is it implemented? So you might have already seen similar diagrams. In React Native, we have two actually most important threads. The first one is one that runs JavaScript code, and the second one is a native UI thread of the like OS-specific UI thread that is responsible for handling gestures or rendering things on the screen. So in this situation, whenever we call that layout animation.spring in JS thread, and then we call set state, there are a list of UI update commands that is going to be sent to the native thread. So, and there is also this middle layer that is responsible for calculating the layout, that is a position and sizes of each of the blocks on the screen. So those commands are first executed by this middle layer that is responsible for calculating layout, which happens asynchronously. And once that happens, then the UI thread actually executes those the actual updates. So what happens here is that we're adding new view to the list to the parent component, and while the layout is calculated, it turned out that there are multiple views that have updated their coordinates, and the UI thread will actually run those updates for each of those views that have updated their coordinates. And this also happens in the animated block. So in the UI thread, we actually the whole animation runs in the UI threads. So once the animation has started, it's migrated to UI thread. There is nothing we can do from the JavaScript side. So there is no way of interacting with that animation, which is good because it gives us a native performance, and also like benefit of using layout animations is that the API is like very very simple because it boils down to just calling a single method. But on the other hand, this only works for layout properties, so the properties that can affect the position and dimensions of elements. And as I mentioned earlier, it's not possible to interrupt this type of animation or make them to be driven by gestures, for example. Yeah. So last method of doing animations in React Native is Animated.js library. This is taken from the documentation. It focuses on declarative relationships between input and outputs. So what does it mean? I'm gonna talk a little bit about later. So let's now focus on API, as I don't think everyone is familiar with it. There was a great presentation last year from Spencer. He was also describing the API of that library. I highly recommend that. So the main building block for Animated.js are animated values. Values can be instantiated this way, as you can see here. So you create new value and you set a numeric value there. So currently, animated values only support numbers. And then when you want to associate that animated value with a view or something that appears on the screen, instead of using view, you can use a wrapper around the view that is called animated.view. It has the same set of properties, but it allows you to, instead of using a constant inside of a style, so for example, you would use style opacity is like 0.5, for example. With animated wrapper, you can, instead of using those constants, you can use animated value. So you can sort of associate that some value with that view that we have created here. And the last thing you need to do is to start that value to animate. And you can do that in several ways. There are different drivers. There is spring, timing, decay, and so on and so forth. So an example here is a spring animation. You call animated.spring, then pass the value to it, and then properties of that animation. So one of the required properties are toValue. So this is a value that we expect the animation to stop at. And depending on the driver, you can also pass additional attributes. So for example, spring can take friction. And the most important thing is that not to forget to call start at the end. And yeah, so the values can be modified. So we can, for example, filter those values. One of the filtering method is interpolation. When you call interpolate on an animated value, you actually create a new animated value that is connected to that previous value, and it takes the first animated value output as an input, and it outputs a interpolated value of that value. Sorry for that. So we can interpolate stuff. We can also combine values. So there are many ways of doing that. An example here is method multiply that takes two animated values, and it creates a new animated value that outputs a product of those two input values. So as you can see, we can mix and match those animated values, and one of the most complex examples of that I've seen is the navigator experimental that Eric just talked about, which uses an animated value as a stack height. So whenever you click on back, what happens there, we actually decrement the stack height, and it actually triggers all the transitions between the views. Right, so let's dive a little bit into the implementation. It has 1,900 lines of code. So let's get started. All right, yeah, I actually prepared a couple of slides to make it easier. So as I mentioned earlier, the basic building block is animated value. So it maps to a node in a graph. So we are going to be creating a graph here, and the nodes are going to be animated values. So the end node is a view that we are going to have this view is going to be connected to a style node that is going to be accumulating the mapping between the attributes and the values. So the style node will also take values as an input, and will store a mapping between those values and the attributes. So for example, another value can map to transition X, for example, and some value that is then interpolated. So interpolation, as I mentioned, creates another node in the graph, and then interpolated some value will map, for example, into a opacity. And at the end of that, we have those animation drivers that are like pulse generators. They just generate a curve and triggers updates of those animated values. And it's all hooked into a request animation frame API that has also been implemented for React Native. So as you can see, Animated.js is actually like a general purpose JavaScript animation library. It doesn't use anything that is native, except from rendering native views, but we can render also other views. So it is, in theory, it is possible to use it for web apps as well. So timing is not the only way of triggering updates for values. Another way is by using events. Animated event allows you to declare a mapping between an event that we get, for example, for a scroll view into a animated value. So in this example, we map the content offset.y property of a scroll event into some value. So this works by creating another node in the graph that is a event node. And yeah, so this is another way of triggering updates. So the evolution of the animated value, instead of being hooked into time-based animation, can be triggered by a event handler. All right, so as you might already know this, the Animated.js is very flexible. It allows for defining any type of animation, as mentioned. The navigator experimental is one of the most complex examples of that. We also can define gesture interaction. You can use animated event for that. You can even update the values manually if you want it. And it's actually pretty performant. You can check examples of that on React Native repo. Yeah, the difficulty is that it's hard to express layout animations because JavaScript doesn't really, like in React Native, JavaScript doesn't really know the dimensions and positions of each element unless you use a layout event, register for layout event. So it's slightly more difficult to express that, but we still have that complementary API that is the layout animation API that we can leverage for the layout animations. But there are also a few problems that I'll like to address during the remaining part of this presentation. So, as you might already know, I've even mentioned this earlier, we have two main threads in React Native. One is the UI thread that is responsible for rendering things on the screen and handling gestures, handling touch events, things like that. And we have JS thread. You also probably know that those are two asynchronous. That was one of the selling points behind React Native. And it's very nice because those run in parallel. There is no chance for the JS thread to block UI thread. So UI thread is not, most of the time, is ready to handle user comments. So one of the examples is that you have, for example, scroll view that has been already rendered on the screen. And once it's rendered, you can scroll it even if the JS thread is blocked. You don't, the UI thread doesn't care because the scrolling is done purely on the native side. So the scroll, we can scroll even if the JavaScript is blocked. So it happens there, from time to time, there is a chance that we want to render something in our React.js application. So when we render things, those are converted into comments that are then transported to the UI thread, and they are going to be rendered. Like the UI thread will create a native components for those, and will render them eventually on the screen. So the render in a JS can be triggered by multiple factors. It could be rendered as a result of a network call that just returned. So, for example, callback from native, or it can be triggered by a timer. For example, the request animation frame timer, or it can be also triggered by a gesture from passed as an event from native. And this is on the next slide. So we have a gesture that happens in native thread, and then when it happened, then we send an information to JavaScript that, hey, there is a event, and you might want to do something about it, right? And if JavaScript decided to change the to render as something as an effect of that touch event, so for example, render a highlight behind the button or something, then the render commands get generated. We pass that information back to the UI thread, and we render things. So you might already see where the problem is with being asynchronous here. So the problem is that when we have this interaction, we expect UI to actually react for whatever happened in the UI thread. But since the UI thread is not actually blocked, then we can, for example, if we have like that scroll view I mentioned earlier that works, even if the JS thread is blocked, and you want to do that fancy collapsible header on top of a scroll view, and you want it to collapse whenever someone scrolls down, then you need to interact with those touch events. But if the JavaScript is blocked, then the interaction might get slightly delayed, but the scroll view will be functional. So you might get out of sync between those changes that you want to do on a header, and the scroll view that will scroll without any interaction with JavaScript. So this is where some people might start shaking, because it's even more complicated than this. And the problem is that there is this mechanism called Vsync that controls and makes our native app to run at 60 FPS. So it essentially splits the bottom axis into chunks. Those are called frames. We have frame 1, frame 2, frame 3. And in each frame, what the native, what the OS will do is it first tries to analyze the input. The input could be like a scheduled task, or it could be a touch event. And then once the input has been processed, it immediately starts composing the frame, because it never knows how long it will take to compose that frame, and we want to have that frame ready before we start rendering next frame. So the issue here is that even if our processing in JS is short enough to finish within a single frame, we won't be able to come back from JS before native threads start composing the frame. So interaction with touch events is also always delayed by a single frame at least. Yeah, and that's a illustration of that issue. So what to do if we have a lot of things running in JavaScript? There is a cool tool. It's called Perf Monitor in React Native DevTools. You just click on that button, and you see this box in the top corner. And one of the most important things is that JS FPS section. So it shows you how many loops have in a JS have finished within those frame boundaries. So if you're dropping frames, JS frames, it means that the JavaScript processing took more than a single frame. There is also Interaction Manager. I'm not going to talk about that. I think Brent is going to mention that tomorrow on his talk. So let's just skip this one. And yeah, and going back to Animated.js, as mentioned earlier, you might think that this is not like the Animated.js is not very special, and it doesn't stand out from other other libraries that can be used for animating in JavaScript, like for example Velocity.js or Rebound. But in fact, it has been designed with performance in mind and with React Native in mind in particular. So the work I've been recently involved with, and after I've left Facebook, is the project is called Offloading Animations, and essentially will allow us to move some of the work that JavaScript does for animating into the native thread. So now what happens is that we have this UI thread and the JavaScript thread, and the Animated.js graph is constructed in JS, and then every frame it's also executed in JS. So what we can do instead is we can generate that graph in JavaScript, then copy it over to native, and run the animation inside the UI thread, and this will supposedly solve all the issues that I just mentioned. So the thing is that it's actually, maybe the greatest thing about this is that it actually works. Yeah, and it's not that difficult to use it. The only thing you need to do is to add this use native driver set to true for whenever you start the animations. Although there are some limitations still, the implementation is still not yet very mature. So it works for Android only at the moment. There is also only a subset of Animated.js implemented. So layout properties are not supported, and they probably won't be supported with the current design. What else? Yeah, and there are also a couple of places in which you might end up actually calling JS by mistake. But yeah. But apparently I prepared this slide a couple of days ago, and this just happened yesterday. There is a pull request for that for iOS by Brandon Withrow. So hopefully it's gonna get merged into master sometime soon. Cool, and that's everything I have prepared for today. So yeah, if you have any questions, I'll be happy to answer those.